Hello everyone. This is Lufuel Digal. We're going to discuss about my project, which is numerical methods. It involves with finding the roots. First, this project covered with numerical methods, which is first is the graphical method, which is it's right here, bracketing method, graphical methods, this sort of thing. Which is we're going to test it with my coding program and explain a little bit of the algorithms. And next is the incremental search method. So it talks about the incremental with delta x, which is very unique, but compared to this, which is bisection, which is a better algorithm, it's sort of continuous finding the root until you reach the exact and approximate root. And then how about the second, which is the fifth, and then this is somehow regular with, it has the same the way of solving from the regular fallacy. However, the second is a bit of different solving patterns, which is involved with formula from xi plus 1 equals to xi, and then fxi, which is the lower bound, and then it will be minus 1 difference with the higher bound, and then with regular or fallacy position. The next is the Newton-Raphson. I'm not familiar with this algorithm. However, this is sort of involves with derivatives, which is sort of very unique, and it is good. So let's straight to the point. We're going to discuss the code itself. So this is as my preferred code, which is the Python, because Python is involved with a lot of libraries and extensions. So I use with the import numpy. Wait, let me zoom this. Okay. So I use this import numpy as an np, which is full with the numbers. It is really useful, which is part of the Visual Studio Code to explain this, and then it will really help, like it will shorten my code to involve such as solving equations, functions, and then the matplotlib, which is involved with graphing, which is very helpful, and then this sort of something of figure canvas and navigation toolbar, which is it helps my code or algorithm to plot the code with the root points, and it will display the values. And then the rest of this are just UI, the panda, and then the same page is just involving with derivatives because we're using Newton-Raphson. And now we're going to use this method, such as this, about graphical. And then you're going to input something here, and sorry, it happens like the Python does not support with caret, which is the powered symbol. So we're going to use double asterisk. It worked. So what happens is that it will generate here the curve, then even the plot, and then along the values, since this is graphical. And let's how about skip this Raphson. So I added the derive function in order to help the user to derive automatically, which is I really love it. It is very useful. So 3 times x plus sin x, and then e by the power of negative x. Then start with x, negative 5, 1. Our initial guess is about the initial guess. I think it's 0.1. I don't know. It's 0.1, and then 0.1 also. Initial guess and the tolerance, which is different. -5 drive. Solve here. So you can see we could just see that the results, which is the graph and even the result of the table, and then it's also show the curved and along the route as well, which is very useful. And then you could also do this, move and then zoom here. You can also zoom there. This, I really like it. Or scroll up, scroll down, and here we go, which is, I love it. And then incremental. So incremental, you could use the 0, 5, 0, and then 1, and then our step size is 0.5. Boom. It generates like so fast. I really like it. And it even explains the remarks, which is really good, until it reach max. So I set the max to 100 to prevent errors, or it causes lag to my PC, which is, my PC is really awful handling this kind of problems. So how about bisection? Okay, 0.4 and then 0.6. So we're going to use the same function, f of x, just here, or we could also use another one. Okay, x minus x. Okay, boom. Which is, I really like it. Python is really good when it comes to this sort of algorithms, and even display, which you could use your formulas in here. Bisection method, I just use the what is on the example, or even the formula, in order to get the graphs and table and the roots. It's very helpful if you're going to see this. Our bisection method. Okay, it explains here, it details the roots, and then this part as remark is really helpful, and it also the example, in order to get this sort of problem, which is just match with the example to your code, in order to get the accuracy of your code, if the algorithm is implying correctly. So how about my Mathlab? Okay, as of now, I use the Mathlab for my another IDE, and I really hate this kind of method, because Mathlab is sort of tricky to use. It's sort of like, but it is really, I realized that this kind of IDE is really good for backends. As you can see here, Mathlab is really centered with the math related subjects, codes, and even the algorithm itself focuses the math, and there's such things as if you're going to install with library from another sources, just like Python, which is because Python is open source, that there's even a lot of documentations and libraries packages database in order to assist your backend. So here, as you can see, you can even see the floats. It's like similar to C# or C++, which is I really like how it's displayed the code, and this is quite a really tricky thing, and I don't even understand what I'm doing, so I look for internet. So I tried. So here, the command window, as you can see, I started with the exponent. So with function L3 times x plus sin x minus e by the power of x. It starts with -5, then 1, end with 1, and then I manually derive this f of x. I tried to like the automatic derivative, but it seems like I cannot do it by myself. Then initial guess with a -5, and then here goes 0.360. So unfortunately I closed the graph, so no worries, I could re-enter it. So 6. So 3 times x plus sin x minus e to the power of x, which is really good because you could even type like there's e caret x, which implies the power of x. It is really simple to see and readable to use, which is Mathlab itself. As of now, I'm using Octave because I don't have access for Mathlab. I don't know why. So we start with x. So our x is -5 and x is 1, and then we're going to derive. So the derive of 3x is 3 plus the derive of sin is cos then x, and then we could not derive the e and the e by the power of x because they are whole number, because it accompany the because e is a whole number. I mean, it's a constant, which is we could not derive. I mean, there are laws of the derivatives. Constant is equal to 0, but e is exception, such as log as well. And then initial guess is -5. We're going to same with the start x, which is -5, in order to get the formula as well here. So we're going to set our stopping criterion, which is tolerance 0.001. Okay, but so it's really small, but no worries. We get the root as well, 0.360412. I'm going to zoom it. Nope, you don't. I don't know why, but seems it's displaying really well. So this is Lufuel Digal. Thank you for watching, and have a blessed day.